in this video, we are going to discuss about memory, location, and addresses. Okay. We know that the computer is having a memory. So we are going to discuss about how it is organized. So the memory, which consists of many storage cells, right? So which is used to store a bit of, it stores a bits of information, right? And which means zeros or one, right? So you know that 0 and 1, which will not hold, it is nothing but a single bit, which will not which will give you only a small information, right? But discuss so usually the how the it is organized is it is organized as a group of fixed. So the information it is stored as a group of fixed size. Say for fixed size, uh, for example, here the memory, for example, I'm going to consider which is organized organized um, of n bits, a group of n bits. Okay, so which can be stored or retrieved. So retrieved means we can take the data from the memory. So how it is means so let me take this is of n bits data. Okay. So this is my first group. So the entire thing is nothing but your memory, right? Uh, so and it is having a addresses, right? So this is the first group, and this is my second group. Second, let me take that group of bits. That group of n bits, I can term it as words. Okay. So this is my first word, and this is my second word. So like this, I can go for last word. Okay. So here the location of this word is termed by the addresses, right? So the location of the each word is given in the addresses. So let me take this one as 0 up to 2 power k minus 1. Okay. So here let me take so here the 2k, it represent address space of the computer. So for example, if we take so you know that we have so suppose we have 4G data. Okay, 4 GB data. So what it represents, 4 GB means uh, 4 I can write it as 2 power 2, and giga I can write it as 2 power 30. Okay, so totally I have 2 power 32 bytes. Okay. So this will be from 0 to 2 power 32 minus 1. This is 0, this is 1, and this one is 2. Okay. And it will goes on up to 2 power 32 minus 1. Oh, word of information, right? It is does nothing but a word of information, group of n bit, word of information. And suppose if n is equal to 16 means it is called as word length. Okay, word length. So usually the word length of the computer, it ranges from 16 to 64 bits. Okay, so you know that 1 byte is equal to 8 bits. Okay, so here you can see if it is suppose let me take this as 32 bits. Okay, if it is 32 bits means I can term it into a 32 bits means it is nothing but 4 bytes, right? 4 bytes is equal to 32 bits, right? So I can term this is nothing but 0, and this is 1, this is 2, and this is 3. So this word length is of so this is a 0th byte, this is a first byte information, second byte information, third byte, and it will goes from 4, 5, right, 6, 7, like that. So you can see, so this here, this is 7, and this is 8, and this is 9, and 10, 11. Likewise, if it is goes on, this must be of though the information though the it is having 2 power 32 bytes, this must be 2k minus 4, right? This must be 2k, that is 2 power 32 minus 4, and this is 2 power 32 minus 3, and this must be 2 power 32 minus 2, and this must be 2 power 32 minus 1. So um, the location of this one is 2k minus 4. Okay. So how the information will be stored? Suppose in the first word, if we want to store in the first word, right? If I want to store um, a number called 8, okay, 8 is a number I want to store. So it has to be of 32 bits, right? So it must be of 32 bits, and it has to be in a signed format, signed binary number. Okay, so signed binary means if it is a positive one, so the MSB must be 0. Okay, and the rest of the value must be rest of it is 32 bit, right? So so this is my bit 31, right? And this is my bit 0. So this has to be, see, so it has to be 32 numbers, right? So it will goes on, and you can see this must be 1 0 1 0 0 1. So this is my B1, B2, B3. It goes on, right? So this is my first word. So this is how it has to be organized. Okay. So otherwise, it should be in signed binary format or it should be in ASIC format. Okay. So it is of 8 bits character. So next one is byte addressability. So we know that the basic information which we are dealing it is in of uh, three ways, right? One is bits, bytes, and word, right? So byte is nothing but 8 bit. 1 byte is equal to 8 bits, and here we are using a word of 16 to 64 bits. So for each bits, we can't able to assign a memory, right? So since we are not for only for the byte location only, we are assigning a address. Okay, so that is why it is called this term. It has came. What it is? Byte addressability, byte addressable memory. Because see, I can't able to assign the memory location for each bits. Okay, so I am assigning a memory location for a group of 32 bits. Okay, here I am going to assign a in this case you can see I am assigning a memory location. This is my memory location 0 1 2 3 and all. It's a memory location we are assigning. It is for um, 8 bits, right? For 8 bits. So that is why it is telling us byte addressable memory. Okay, so the byte locations 0 1 2 up to 2 power here 32 minus 1 I have assigned. So usually we are assigning it from left to right, right? Starting from left and ending in the right. And it is also in the successive, we are assigning in the successive locations. So here you can see um, if we are assigning the MSB, that is like this, right? So this is my MSB, this is my MSB, right? And this is my LSB, right? So if we are assigning 0 to MSB and 3 to LSB means this type of assignments, right? It is called as big Indian assignment assignments. For MSB, we are assigning a lower order, lower byte address. Okay. Whereas for Little Indian, LSB is assigned as 0. Okay, it's opposite to that of big Indian. So you can see if I assign 0 to this one 1 2 3 and this must be 4, right? 5 6 4 5 6 7, this must be 8, right? So it has to be 2k minus 4. Okay, so this is nothing but your big Indian assign. Suppose if I assign 0 1 2 3, then starting from here 4, 5, 6, 7, 8, 9, 10, 11. From here it becomes 2 power 32 minus 4 minus 3 minus 2. So this is called as little Indian assignments. Okay. So here also you can see the address is taking a successive words in the memory of the computer, which is of 32-bit word length. Suppose 0 represent you have 32 zeros, right? You have 32 zeros. So this is how the address, the word address must be of 32-bit length. So the 0 also it is address, right? So this is address and this is also of this is called as byte address, right? So the byte address is also of the length 32-bit length, right? So the next one is word assignment. So here the word locations, word alignment. So here the word locations have aligned addresses. If they begin at a byte address, that is a multiple of number of bytes in the word. So the number of bytes in a word is usually of power of 2. So it should not be 30 bytes. It should be in the power of 2. Then only we can either 16, 32 and 34, 32, then 64 like that. Okay. So usually it is of you should not have if the C can the word address is started with 0. So suppose if it is starting with 2 or 3 or some other arbitrary byte address, then we can tell it as unaligned address. Okay. So what is unaligned addresses? Unaligned addresses. So instead of 0, it starts with some other arbitrary byte addresses. So we can see accessing next one is accessing numbers and the character. So usually for accessing the character, accessing the number, we use a word address. Okay. So because it actually occupies only one word. Okay. So we were using word address for that one. For individual character. So for individual character, we use byte address. So next one is memory operation. So you know that all the instructions, right? Instructions, it is a program instruction, right? And the datas. are present in the memory, right? So in order to execute that instruction, the control unit in the processor must causes the word containing the instruction to be transferred from the memory to the processor. So whatever the um, data or instruction in the memory has to be comes to the processor. So this can be done with two basic operations, right? In order to move the data or results from the memory to processor, we are using two operations. So one is two basic operations. One is read, okay. Other one is write. These are the two memory operations. So what is read means we are going to copy the content from the specific location of the uh, from the specific location from the memory to the processor, right? So if I copy the data, if I copy the content, it will not get erased in the memory, right? So the content is there in the memory and also in the processor. So this is what we would call it as a read operation. So what it will do is to start the read operations, the first one is the so so once the process in the address of the display location of the memory, and it would request the content that is to be read, the memory will read, okay. The memory read the data stored at the address, and it will send to processor, okay. So this is called read operation. So what is write operation means? So here also we are going to write something in the memory, right? So here also the processor, so what are the data that is so once if we write into the memory, the already the content in the memory get erased, right? So it will overwrite the former content, okay? Former content which is present at the location. If you perform the write operation in the memory, right? So how to initiate the write operation? So in order to initiate the operation, the processor will send the address, right? Address of the display location of the memory location to the memory, right? Plus it will also send the data that to be written, right? So next the memory will then uses this address and data to perform the write operation. Okay. So far what we have studied, mm, we have studied about memory locations and address. So usually we store what for the memory is used in order to store the data. It will store the data in terms of bits. Bits is of zeros and ones. Since it contains very small information, it has to be in the group of fixed size. So let me take that one as 32 bits. If it is 32 bits means the memory location is from, that is the word address is from 0 to 2 power 32, 0 to 2 power 32 minus 4. So if I assign and you can see since the word length is 32, 32 bits, I can split into 4 bytes. Okay, so it ranges from 0, 1, 2, 3 for the first word. So the 0 represent a byte address. So if it is from if I assign LSB as 0 means it is nothing but little Indian. Suppose if the MSB is 0 means it is called as a big India. So next, so here the in order to so the byte, what is byte? Byte addressability means so since we are using a byte address, okay, for storing the group of bits, so it is called as byte addressable memory. Then the word alignment means so here the memory, the word address is starting from 0 means it is called as aligned address. Okay, suppose if it is start with some other arbitrary byte address means then it is called as unaligned address. Then we have discussed about accessing numbers and characters. In order to access the numbers, we use a word address. In order to access a character, we use a byte address. So there are two types of operation in the memory. One is read and write. So in the read operation, what will the processor will send the location where the information has to be read in the memory, and also the data. Okay, data I want to read. Okay, so the so that address then it will send them to the process. This operation it will copy the content, so it will not get erased. Whereas in the write operation, it will overwrite the former content of the location. So what does the process means? The processor will send the address of the location, address of the desired location plus data that will be written in the particular location. So the memory uses the address and the data in order to perform the write. Okay. So I hope this video is useful for you. Thank you.